sir, because of this LPG gas issues. I was asking in that way.
Okay, dude. Yeah.
Ma'am,
The institute is working. There is no issue in case of LPG gas issues. In MANIT Bhopal, there is no issue.
Madam, live stream started, ma'am. Shall we start?
No, ma'am, it's not yet started. Ram Shankar, sir, shall we start, sir?
Yes, ma'am, but I gave the live stream session, ma'am. I think it started.
Yes, it
Yes,
is
it
fine.
started. It started. It started. So, shall we start, ma'am?
Yes, ma'am.
Good morning to everyone present here. On the behalf of Department of Civil Engineering of RMK Engineering College, I extend a warm and heartfelt welcome to our esteemed speaker today, Dr. VIKAS POONIA, Assistant Professor, Department of Civil Engineering from the MAULANA AZAD National Institute of Technology, MANIT, BHOPAL. We are delighted to have him with us today for the generic talk series on climate extremes. Climate extremes are becoming increasingly significant in the context of infrastructure resilience, environmental sustainability, and disaster management. Today's session will provide valuable insights into understanding these challenges and the scientific approaches to address them. I also extend my warm welcome to faculty members, researchers, and students who have joined this session via YouTube. We hope that today's talk will be informative, inspiring, and thought-provoking to all of us. Once again, I welcome you all and look forward to the highly enriching session. I now welcome Dr. L. Andal, HOD, Department of Civil Engineering of RMK Engineering College, to introduce the chief guest to our gathering.
So, thank you, Ishwarya, ma'am. Good morning, all of you. On behalf of our management, our Honorable Chairman, sir, and Honorable Vice Chairman, sir, our Principal, sir, and advisors, sirs, I welcome you all for this generic talk series on the topic climate extreme. It's my great pleasure to introduce our distinguished guest speaker, Dr. VIKAS POONIA, to this esteemed gathering. Dr. VIKAS POONIA is currently serving as an assistant professor in the Department of Civil Engineering at MAULANA AZAD National Institute of Technology, Bhopal. Prior to joining MANIT, he served as an assistant professor at NIT Calicut, where he contributed significantly to teaching and research in the field of civil and environmental engineering. Dr. Poonia completed his PhD in water resource engineering from Indian Institute of Technology, Indore. His doctoral research focused on drought occurrence, evolution, and its impacts across India, an area that is critically important in the context of climate variability and water resource management. His academic journey also includes prestigious postdoctoral research positions at the premier institutions like IIC Bangalore and Purdue University in United States, where he expanded his expertise in advanced hydrological and climate-related studies. Dr. Punia's research interest spans several cutting-edge areas, including hydroclimatology, climate change impact assessment, hydrometeorological extremes, and data-driven environmental modeling. His work is particularly significant in understanding how climate variability influences water resources and environmental systems, which is crucial for sustainable planning and disaster mitigation. He has made remarkable scholarly contributions, having authored more than 20 research articles in reputed journals, one book published by Springer, and 13 book chapters in internationally recognized publications. His research excellence has been recognized with several prestigious awards, including GM Navthi Puraskar in the year 2024, Professor UC Kothari Best PhD Thesis Award, and Sista Young Scientist Travel Award, and the Best Paper Award in the year 2023. Currently, Dr. Punia is actively leading and contributing to important research initiatives. He serves as the principal investigator of an ANRF funded project focusing on flash drought hotspots across India's major river basins. In addition, he is a co principal investigator in ANRF and ICSSR funded projects that examine drought linkages and socio environmental adaptation strategies. His research integrates climate data, hydrological analysis, and remote sensing techniques to better understand hydroclimatic extremes and their impacts across India. Dr. Poonia's work not only advances academic knowledge but also contributes to addressing real world challenges related to water security, climate resilience, and environmental sustainability. We are indeed fortunate to have such a distinguished researcher and academician with us today. I am confident that his insights and experience will greatly benefit our students and as well as our faculty members. On behalf of the department and behalf of our college, it is my honor to warmly welcome Dr. VIKAS Poonia and invite him to share his valuable thoughts with us. Over to VIKAS Poonia, sir. Thank you so much, sir.
Thank you so much, ma'am. HOD Department of Civil Engineering, RMKEC Engineering College. Thank you so much for inviting, and also thank you so much for Dr. Aishwarya, the coordinator of this particular generic talk series. So first of all, I'm very thankful that I got opportunity to share my research with your faculty members, researchers, and students of this of your college. So I will share the screen initially. I think sharing is disabled. Can you enable it?
Sir, access given.
Yeah, okay. Yeah, okay, thank you. So my screen is visible?
Yes, sir.
Yes,
Okay.
sir.
So first of all, a very good morning to all of you, and thank you for this particular opportunity to give an expert lecture in the Department of Civil Engineering at RMK Engineering College, Tamil Nadu. And the topic of today's presentation is climate change and the climatic extreme events. Means what this climate change is and how this climate change leads to the climatic extreme events. So initially we will try to understand what this climate change, how this climate change is playing a crucial role across India or globally, and then we can say what are the different effects of climate change and how this climate change is going to lead or is causing the climatic extreme events across globally as well as the India level also. So first of all, we need to understand what this climate change is. So wherever we are going, either we look at a TV or documentary or broadcast or conferences, short-term training program, expert lecture, anything, everywhere we are looking at a climate change, that this international conference on climate change, this expert lecture on climate change. But the very basic question which we need to discuss is whether this global warming and this climate change are same or not. So obviously both are not same. Global warming and climate change are one of the different aspects. We can say global warming is not climate change, but it is one of the factor which is causing the climate change. So what is the basic difference between them? So we know very one basic difference, that is that if we talk about global warming, we can define that it is a gradual increase of Earth's surface temperature. We know that due to greenhouse gas effect, whatever the shortwave radiation we are getting on the Earth's surface from the atmosphere, when they are going radiating back to the atmosphere due to greenhouse gases, that radiation is going to be trapped due to these greenhouse gases, and due to this trapping of heat, obviously the Earth's surface temperature is going to increase. So this gradual increase of Earth's surface temperature is defined as a global warming. However, if we talk about the climate change can be defined as a long-term change in a global weather patterns. Global weather patterns means we can say whatever the events we have in terms of high precipitation or low precipitation, or we can say temperature or relative humidity, sunshine hour, when these weather patterns, either it is temperature or precipitation or humidity, if we are observing a long-term change, means it can be 30 years or more than 30. Minimum, as per the scientist, we need to take minimum 30 years in order to say whether there is a climate change or not. When these global weather patterns, either it is precipitation or we can say temperature, when there is a long-term change in these patterns, more than 30 years, 50 years, 100 years, or more than that, then we can say, yes, there is a climate change happening. And as per the climate scientist, more than 97% of the climate scientists agree that climate change is happening. Further, we need to understand what is the importance of climate change. What is the reason why we are much more focused on climate change? What is the urgency? What is the importance of this topic? So if we talk about former United Secretary of the Treasury, he said that a climate change is the single biggest risk that exists to the economy today. And as per the United Emission Gap Report in 2019, they say that we are on the brink of missing the opportunity to limit the global warming to 1.5 degrees Celsius. However, as per the international agreement, initially they have set a threshold that to limit the global warming, we must limit this global warming, or to protect ourselves from the climate change, we have to limit the global warming to 2 degrees Celsius, which is the condition. However, we desirably limit this global warming to 1.5 degrees Celsius. In 2019 report, we got a alarming situation or a warning that we are on the brink of that limit. Means we are just try to miss this opportunity, that we cannot available, that we are not significant enough, that we are limiting this, we are not able to limit this global warming to 1.5 degree. And if we are not taking care of this climate change urgency, and we are not understanding its importance, so obviously we will cross this 1.5 degrees Celsius very soon. However, if you look at 2024-2025 itself, we have already crossed this 1.5 degree threshold, and right now we have a threshold of 2 degrees Celsius, that we must limit the global warming to 1.5 degree Celsius. There is also a statement given by Mark Carney, who is the governor of Bank of England, which clearly indicates that the companies or the nations or anything related to anything say that if we are not going to adapt to the climate change, obviously we will go bankrupt without any question. So every company, every institution, every nation have to adapt the climate change. Otherwise we will go bankrupt without any question. So this is the importance of climate change. This is the urgency which is related to climate change. So this is related to on a global level. Then as a researcher, as an academician, as a researcher who works on the climate change, why we need to care about climate change? Because whatever we have discussed, that is on a global level, on a GDP level, on an economy level. As a researcher, why we need to care about the climate change? So we need to care about climate change because there are several risks which are associated with the climate change. For example, we can talk about the flood events, we can talk about the drought events, cold wave events, heat wave events. There are different risks which are directly associated with the climate change. If climate change is going to happen, the number of flood events, drought events, heat wave events, cold wave events are going to increase continuously. So that is a direct risk which is associated with that. However, there are several indirect risks which are associated to the climate change, but maybe we are not looking directly to them. Because, for example, if drought is there, obviously in a region where drought is continuously occurring for so long, like 10 years, 5 years, 2 years, like that, so obviously the population of that particular region is not going to be there for so long. So they have to migrate from that particular place to any other place itself. So that due to drought, we have an indirect risk of population migration. For example, if there is a flooding event continuously in every season, every monsoon season of a year, then obviously there is a chances of disease spread, means waterborne diseases. So obviously that is also a indirect risk which is associated to the flood, which is directly or indirectly related to the climate change. Maybe due to flooding events, there is an infrastructure damage, there is a damage of agricultural production, and we have low water supply, which is freshwater, which is in freshwater form itself. So we can say that due to this climate change, there is a high risk of temperature rise. Means temperature is continuously increasing, and due to this increase in the temperature, we are frequently observing hot days and warm spells very fastly, and due to that we are also observing a new term, that is urban heat island effects in the cities itself. Further, we have a flood risk events. We have seen that there is an increased number of flash flood events. Even in the last year itself, we have seen an example of Dharali in Uttarakhand. We can see the example of Punjab. They have experienced a very significant flooding event in the last year of 2025, Kedarnath flash flood condition like that. And also at this present point of time, it is also very important that due to this climate change, we are not observing only a single type of extreme event, either it is flood or drought. However, there is a very significant combination, we can say, or very deadly combination, that there are occurrence of more than two extreme events at a particular time. For example, compound flood and drought conditions, compound drought and heat wave conditions. So if we are facing any particular one extreme event, either it is drought or flood or heat wave, that affects the our ecosystem very badly. However, if two or more than two extreme events are also occurring continuously or simultaneously, so you can imagine how this climate change is happening and how this climate change is leading to such number of climatic extreme events in a together form, means flood plus drought or drought plus heat waves or extreme precipitation plus flood. So obviously the risk associated with the compound events is very high as compared to the effect of a individual extreme events. Then there are several risks which is associated with the drought conditions, like it reduce the arable land productivity, it will leads to the reduction in the crop yields of wheat, rice, maize. These are the major crops we have in India. Insecurity of fresh water availability, and there are high chances of water related diseases, means waterborne diseases, the spread of waterborne diseases like that. So what are the 5 critical global environmental changes of climate change? So the very first is a warming temperature, then changes in the global water cycle, declining of glaciers, because we know that if there is a more temperature, increase in the temperature will be there, and obviously it will affect the change in the global water cycle. We know that there is a particular water cycle we have, which starts from the evaporation or transpiration, which results into the formation of clouds, and that clouds are moving from high temperature condition to low temperature conditions from with the help of the wind speed or with the help of wind. And once they come from the low temperature condition, high temperature condition to low temperature conditions, they got cooled down, condensation take place, and finally they result into the formation of precipitation. Further, that precipitation also leads to join the water bodies in more or less any particular significant time itself. So this is a water cycle we have. But due to this climate change, there is a complete alteration or modification in the global water cycles. And due to high temperature condition, whatever the glaciers we have, snowpack we have, it is also declining, or we can say retreating of the glacier is taking place in the era of climate change. And due to this glacier declining, or we can say the retreating of the glaciers and snowpack, it will result into the sea level rise and the ocean acidifications. So whenever we talk about the climate change, what the proof we have in terms of the climate change, whether the climate change is going to happen or not. So if we talk about this climate change, how this climate change is going to happen, we have some example, or we have some facts of climate change at a global level. So this is a data which is given by World Meteorological Organization, which is from 1970 to 2019, around 50 years. So you can see that here they have represented the data on a decadal basis, means from 1970 to 80, 80 to 90, 90 to 90, 2000, 2000 to 10, and 10 to 20, like that. And you can see that every single decades, the number of reported disasters are continuously increasing. Not even 10% or 5%, they are just double of that. For example, the very first is 1970 to 79, and the number of reported disaster is 711. However, in the next decades, they are more than 10 times, twice of that. That is 700 is doubled to the 1400. Then more than that is 2250, then 3500, like that. Similarly, due to this number of reported disaster, the economic losses is also very visible. That here initially it is 175 billion US dollar, then it becomes 289, then it becomes 852, then 942, and 1381. At every single decade, number of reported disaster as well as the associated loss is continuously increasing. However, we can say one thing which is positive in this aspect, that the number of reported deaths are decreasing. Why it is so? Because we are taking, or we are spending a lot of money for the disaster mitigation and prevention strategies on a global level as well as on India level. That's why if we are paying, or if we are investing a lot of money in disaster mitigation strategies, obviously we can reduce the number of deaths due to that itself. Therefore, you can see there is a decline in the reported deaths, but increase in the reported disaster and increase in the economic losses due to this disaster on a global level. So on an average, we can say, or that the more than 11,000 reported disasters we have, and more than 2 million deaths due to this disaster, and we have experienced a loss of more than 3.64 trillion US dollar loss globally in past 50 years, from 1970 to 2019 itself. So this is all about the effect we have on a global level. Then how this climate change is happening, or what the proof we have of this climate change across India level. So here we can say that more than 50% or 54% of India is facing high to extremely high water stress condition. We have example of a Bangalore city and other various metropolitan city across India. We are vulnerable to the water stress condition, we are vulnerable to the flood conditions, we are highly vulnerable to the heat wave conditions. I think in the last year 2025, even if you can see in the next coming some months like April, May, June, July, you can see the heat wave condition and the effect of heat wave condition. Either we talk about the national capital Delhi or any other places related to heat waves in India. The major important thing which we have already discussed when we talk about the extreme events or direct risk associated with the climate change, that for example, we have a newspaper clipping of India Today where they say that some parts of Maharashtra, they are facing floods. However, after some days, they are also facing the drought-like conditions. So this is the deadly combination of extreme climatic events any particular region can have. Initially, for some months, they are facing flood condition. However, after some time, they are also facing the drought-like conditions, means flood simultaneous occurrence with the drought-like conditions. So this is the most deadly combination of the climate change or climatic extreme events for a particular farmers of any particular region itself. For example, if a farmer initially faces the flood conditions, obviously, it will significantly affect the cropping pattern or agricultural losses he have to face due to the flooding events. And further, due to drought-like conditions, obviously there will be no agriculture production due to the drought-like conditions. So this is a very deadly combination for any particular farmer and their livelihood conditions, because they are mostly dependent on their on the agriculture for their livelihood itself. Further, we are also very vulnerable to the urban flooding conditions. And the very important thing related to climate change is that if this climate change is going to happen as of what we are facing right now, if this continue in the next 75 years up to 2100, means next 75 years, some of the study claims that the Himalayan glaciers risk losing 75% of their volume by the year of 2100 due to this particular global warming issue. So we can say that as India, we have a large population of large proportion of global population and highly vulnerable economic activities. We are at high risk of climate change because we are vulnerable to the flooding events, drought events, heat wave events, and extreme precipitation events. For example, a study has been carried out in 2017 by Roxy et al. And they clearly mentioned that in last 65 years, from 1950 to 2015, we have observed a thrice increase or threefold increase in the extreme precipitation events across India itself. So obviously, we are highly vulnerable to the climate change and the climate extreme event. Either we talk about flood conditions, drought condition, heat wave condition, extreme precipitation condition, or the compound of these, either it is drought plus heat wave, flood plus extreme, or like that itself. So it is the warning for all. And why this climate change is happening, the major, we can say the maximum possibility reason is the urbanization. Because continuously in this era of industrialization or urbanization, we are continuously expanding the urbanization or urban areas in last some decade itself. For example, if we talk about the urbanization in India, we can say, or across globally also, that this due to urbanization, more than 55% increase in urban water demand is going to be expected by the 2050. Means in next 25 year itself, or 4 years, we are going to experience 55% more demand for the urban water itself. And more than 2/3 of the global energy supply is consumed by the city only. This is the urbanization we have. More than 70% of greenhouse gases emission is also from the cities itself. Mostly, if we talk about the low-income countries, they are not going to manage their waste. So more than 93% of waste is unmanaged in low-income countries, especially like Asian countries, some of the Asian countries we have. And then more than 2.6 to 1.3 million square kilometer of new built urban areas are expected to be added in the next 25 years or like 30 years like that. And the major thing which we need to focus on is that more than 2.5 billion people will join the cities by 2050. So you can understand that if this urbanization is going to place, because more than 2.5 billion people is going to add in the cities itself. So obviously the water demand, the energy supply, the greenhouse gas emission, this new built up area will be also increasing significantly, or we can say it is increasing very exponentially. And obviously directly it is related to the climate change, global warming, like that. So it is a very alarming situation on a global level as well as on India level, that we must need to understand why this urbanization and how we can control this urbanization issues which are directly related to the global warming and climate change. And we need to limit this global warming by 1.5 degree, because this is the threshold where we can say that if we are controlling this global warming to 1.5 degree, the impacts associated with this particular 1.5 degree threshold is not very high. It is not very severe impacts associated with 1.5 degree. But if we are crossing this limit 1.5 degree Celsius, obviously the impacts associated with the more than 1.5 degree Celsius is very severe, very expensive impacts we have to face due to this threshold of 1.5 degree or more than that itself. So these are the things which we have discussed, that what is climate change, what are the proof we have, and why this climate change is going to be happen, and what are the impacts associated with this climate change. Then what on a global level or on a national level, what the authorities are doing to combat with this climate change, to mitigate this climate change, to protect us from the climate change. So if we talk about India, we have a national action plan on a climate change, which initially started in 2018, in which they have divided this national action plan on climate change for each state. Therefore, they have developed the state action plan on a climate change there, and this state action plan on climate change further installed two bodies on a state level, that is state climate change cell and state knowledge center on a climate change itself. So all the data is collected by the state level, and then it is shared with the national action plan on a climate change itself. However, if we understand what is the current position we have, where do we stand right now in mitigation or in prevention of prevention from the climate change at a national level or on a Asia level. So we have a mission named as Smart City Mission, which is started by the Ministry of Housing and Urban Affairs, Government of India. So Smart City Mission means a mission which talk about the sustainability, sustainable environment. Means we need to provide a decent quality life to our citizens by providing a clean and a sustainable environment. Means we have to apply the smart solutions for each and every single problem exist in the urban level. But there is one problem we can, or not a problem, but we can suggest, or we must include one of the important point in terms of smart city missions. However, they are trying very best in smart city missions, we have to appreciate. But only the thing which we can add, or we can suggest, that we can add some plans or policies for the estimation and mitigation of risk due to the climate extreme events. Because right now we may not have this particular plans or policy for estimation and mitigation of risk due to the climate extreme events. But if we include these plans or policies, obviously it will be more beneficial whenever we are developing the smart cities across India itself. Further, there are several government initiatives for this climate risk management on a state level itself. So the major point of concern on which we need to focus is that what are the reasons why, because of that, we are not able to track this climate change, we are not able to protect ourselves from the climate change. So the major reason or major point of concern and limitations associated with this climate change is that if we talk about India, we do not have a proper scientific information database. Means we do not have a insufficient observational, or we can say, scientific information database. If we have a proper database, so obviously we can have the proper information that what are the drought events which already faced we have in our particular region. For example, if I am from Bhopal, what are the drought events we have faced in the recent 2 decades or 3 decades? So based on that, we can have a proper implementation policies. Further, the second important thing, whenever we talk about a climate change, we usually have one thing in our mind, that if climate change is happening, obviously it will affect the agriculture sector of economy. But it is not like that. It is having effect on all the sectors of economy. But whenever we talk about climate change, more or less, we are just relating this climate change to the agriculture. But this is not true in this case. If we talk about climate change, it have effect on every sectors of economy. Either we talk about agriculture, natural ecosystem, health, biodiversity, coastal sector. So we must understand what this climate change is and how this climate change is going to affect different sectors of the economy. The further third important thing is the connectivity. If as a researcher, we are doing the research by sitting in an AC room, and we are doing the research that how this climate change is going to happen, how the drought events are going to happen in particular region, and how this climate change is affecting the agricultural production of any particular region like Bhopal. But that research is published into a paper will not serve the purpose. Why? Because that research is more or less, we can say, it is useful to the end user, and end user is the farmer itself. But we have a very poor connectivity between the knowledge generating communities such as researcher and the end user like farmer. We have a very poor connectivity. Whatever we are finding out in a research, whether, for example, if we talk about the impact of climate change on crop production, or we can say the irrigation requirement, and if we go to know that if we can shift this irrigation period from this to this, it will helpful to the farmer get more agricultural production. But that research itself is lying in that particular research paper, and we are not able to aware the farmers at the end, so that they can change that, they can shift their irrigation period or growing period. Then there is no sense of that research itself. Therefore, this poor connectivity between knowledge generating communities and the end user is also very big concern or limitation in terms of climate change. Further, right now we do not have any frameworks, proper framework which can incorporate the time evolving climatic parameters, because we must have an idea, we must have a data that how these climatic variables are changing on a real-time basis itself. Real-time data set is also very required. Therefore, we can say there should be a proper risk information conveying platform which gives clearly what is the risk associated with the drought, what is the risk associated with extreme precipitation, what is the risk associated with the heat waves, their compound events like that. And this platform should be given to the general public in form of an app. For example, we are using WhatsApp app on a very frequent basis, means every single normal common people can know how to use the WhatsApp as an app itself. So if we are providing an app to the common public or general public, and in that app itself we are giving the information of different drought events, flood events, or extreme events, and what are the risks associated with them. So as a minimum, at the administrative peoples like collector or authorities at urban local level, or we can say on rural level, they can understand what is the risk associated with the drought in their area, what is the risk associated with the flood, heat waves, like that, because they are not related to the research field directly. But if they get an idea that what is the risk, because this app should give the information in a very general way, not in very research oriented way. So as an administrative, they can understand what is the risk associated with different climatic extreme event in their particular region. So based on that, they can do some preventive or mitigation strategies in the coming years, and they can change their policies, or based on that they can recommend the policy recommendation or policy change related to the prevention and mitigation strategies of the climatic extreme events. Then so we must need a e-tool that can assess the risk very properly in any particular region. So we need to develop a tool that can estimate that what is the climate risk and how we can assess it, so that it will provide or it will fulfill the requirement of this climatic risk assessment platforms. And this tool will be very useful in terms of institutions, government bodies, researchers, students, private firms. They can use this tool for the research, for the policy recommendation, and everything like that. So we can develop a tool which is related to extreme climate risk and resilience estimation and assessment tool, where we try to understand what is the integrated online risk visualization platform. We must go for not only for single risk assessment, we must go for single as well as for multi-hazard, because in this era of climate change, we can't say we can't talk about a particular event itself. We know that drought and flood are also occurring simultaneously, drought and heat wave are occurring simultaneously. So we must go for the multi-hazard risk assessment, because it will help to serve the purpose rather than single hazard risk assessment. Further, we need to identify what are the drivers, whether it is human driver or a natural drivers of flash drought of this particular extreme events. What is the vulnerability and exposure, so that we can calculate the risk also. So this tool should be means this can be generated like this. For example, if a tool or a website where we have this risk estimate tool, where if we click on this risk estimate, we can have the high rainfall risk and the maps associated with that. If we click on the second sub tab of risk estimate is a drought risk, and if we click on this drought risk, we can have the it can generate the map of drought risk associated for the global level or for the India level. So if we develop a tool or a portal where we can have high rainfall risk and associated map, drought risk and associated map, risk to the ecosystem and its associated map, where it can show this is the low risk, this is moderate risk, this is high risk, or this is the extreme risk. And the resilience means how much we are resilient towards the impact of climate change. So this portal is very required, where we can have different risk associated with the different extreme events and the map directly associated with these risks. Further, however, sometimes this only this map will not help us out. So we must need to have the data download and the map download, because sometimes we need a data, sometimes we need a maps. So both toolbox or download should be available on a portal on a India level, where we can download the data, where we can download the risk map, where we can download the resilience map for each and every climatic extreme event and their compound events as well. So this is very important. Further, we must know what these climate models are, because whatever the information we have for extreme events, either it is drought, flood, heat wave, or any other extreme events, we can calculate these extreme event and their frequency and their characteristics like duration, frequency, their characterization we can do only for the past period. But obviously it will not help us to understand what will be the possibility of these extreme events in the future. So for that, we must have an idea, or we must have a data for the future climate. So for future climate data, we must go for the climate models. Climate models means nothing. It is a simplified representation of a system or a concept or a process which is used to define, which is used to describe the real world phenomena, means how this climate is continuously working. So we represent this climate in a form of model, either with the help of physical model or numerical model. Numerical means we are using some equations. However, in case of physical model, we try to depict the climate in a physical form. Whatever the physical things we can produce, we try to produce in a model form, and then we'll try to model the climate itself. So these are some of the most widely used global climate models, which provides the data of future, means from 2025 or 2026 to 2100. For the next 75-80 years, it provides the data. And the most widely used, means the latest generation of global climate models, that is frequently known as GCMs, global climate models. So CMIP6 is the most widely used data sets, which provides the precipitation data set of from 2025 to 2100, precipitation data it provides. So these are some of the data sets which we can have from the global climate models. Then the further important concept which we need to discuss in this particular lecture is extreme events. So because this lecture is a combination of two things: climate change impacts and what these climate extreme events are. So climate extreme event is, if you want to understand on a very simple basic way, you can understand by one particular thing, that for example, extreme means anything which is going above the level, means extreme. How we can define the extreme? For example, let's take an example of precipitation, or example of we can say the temperature. For example, we take an example of temperature. So for any particular region, either it is Bhopal or like Madhya Pradesh or Tamil Nadu or any particular city, we have a particular range of temperature. Okay, so if that temperature is having a lower threshold and a above, means the upper level threshold, and the temperature is ranging between the lower threshold and upper threshold. So that is the temperature conditions we have in our particular region for so long. However, when this temperature is going above the threshold or below the threshold, it means it is going below the threshold, that is also an extreme event. If it is going above the threshold, that is also extreme. When it goes below the threshold, then it leads to the cold wave events. And when it is going above the threshold event, in case of temperature, it will result into the heat wave event. For example, the same case we can take an example of precipitation. If there is a lower threshold of precipitation, there is a higher threshold of precipitation. If this precipitation is going below the threshold level, obviously it will result into the drought events, because if the precipitation is going below the lower threshold of precipitation, means lack of precipitation, obviously it will result into the drought-like conditions. However, if this threshold is going above the upper threshold of precipitation, obviously it can result into the extreme precipitation event, or we can say the flooding events. So whenever any climatic variable, any weather variable is going above or below a threshold value, or it is near to upper value or near to threshold, upper threshold or lower threshold, then we can say it can result into the extreme weather event. For example, higher of temperature leads to extreme weather heat wave events, or extreme of precipitation will lead to extreme precipitation or flooding events, or lower of threshold, precipitation below the lower threshold of precipitation will lead to the drought-like situations, we can say. So this is all about the extreme events, and how this climate change or climatic extremes are defined, or how this climate change or extreme events are happening, you can see from the figure. For example, this figure we have. So this is the climate we have previously, like this. For example, if this climate change is happening and this climate is going to be changed from this to this particular place, means from this previous climate, we are shifting some mean from this particular this mean, it is shifting to this particular mean. So you can see that if this is going to be shifted from this place to this place, we may have less cold weather events, because it is related to temperature itself. So here you can see these are showing the cold weather events. So initially cold weather events are like this itself. However, due to shifting, cold weather event is going to be decreased or it is reduced. So it is positive one. However, if you look here itself, this is the extreme means we can say heat wave events. So this is going to be increased. So here, due to change in the climate, we are recording less cold weather events. However, we are recording more hot weather events. Similarly, if we talk about the variability, initially it is the shape of the climate is like this, but then further it is having the more variability. It is more spreaded, not more concentrated. And if it is going to be more spreaded, the cold weather event is also going to be increased and the hot weather events will have to be going increase. So you can see a small change in the variability, small change in the mean is continuously increasing the extreme event. So we cannot say that a small change in the climate event is not going to do anything. It will not going to affect the climate events. No, it will affect. You can see change in mean, change in variability. For here itself, you can see the change in the shape. You will see that if there is a change in the shape, more hot weather events are observing. However, in terms of cold weather events, there is no big change, not big decrease or increase, means it is more or less constant. But in case of hot weather events, means heat wave events, we are observing continuously increase. Either it is a change in the shifting of mean or increasing the variability or changing the shape of the climate data itself. So you can see in this, and whenever it is changing either in mean, variability or shape, obviously it will result into more heat wave, more flood, more droughts, more cyclone, like that. So this is all about the climate extremes. And there are different types of climatic extremes we observe. For example, if you talk about the meteorological extremes, we observe different type of meteorological climatic extremes, like in terms of cold waves, heat waves, extreme rainfall. If we talk about the hydrological extremes, we face flood, drought types events, flood type of extreme events, drought type of climatic extreme events. If we talk about the climatological extremes, we face wildfire events, hurricanes, cyclones. We know that these events are very, very important. And if we talk about India, we are highly vulnerable to the drought. Means we can say India is one among the most vulnerable to the drought-prone countries. We are one among them. We are also vulnerable to the flood events. We are highly vulnerable to the heat wave event, extreme rainfall events. And if we talk about the fire, that is also very important, because if we talk about India, these fire events are also very increasing due to this climate change and the human activities, especially in the area where we usually practice the shifting cultivation. We say chum cultivations. So they are also very one of the type of a climatic extreme events. And these forest fire have become increasing environmental, or we can say the global environmental challenge, or we can say disaster management challenge across India. So we must think about these type of climatic extreme events due to this climate change. Either it is hydrological extremes, climatological extremes, or we can say the meteorological climatic extremes. So here we can discuss different types of climatic extreme events. We have heat wave versus cold wave. So you know what this heat wave is and what is cold wave. Means whenever we have a prolonged period of excessively high temperature. So there are different definition given for the heat waves. For example, we have a definition given by the India Meteorological Department, where they have defined the heat waves for different regions, for the area which is having mean temperature of 40 degrees or above than that, and for the area which have the mean temperature of that particular area less than 40 degrees. So they have defined in that way itself. So whenever we talk about excessive high temperature for a longer period of time, then it becomes a heat wave. And obviously it have a very high risk impacts, like in terms of health. For example, if we talk about heat waves, pregnant women or elder peoples or women, they are having high risk as compared to others. Then cold waves, obviously whenever we have an extreme cold or extended period of cold waves, so obviously it will affect the energy demand or like that. Then further we can say the other climatic extreme events in terms of floods and drought. And we know that India is one among the most vulnerable drought-prone country in the world, with at least one drought occurred in every 3 years in the last 5 years. This data is very important because we say that drought is one among the India is one among the most drought-prone countries in the world, which where we have high probability or high likelihood of the drought events. So this is very important. Climatic extreme events we have in India. Either we are drought is defined as meteorological drought events, hydrological drought events, or agricultural drought events, and we are facing all these three drought types. Even there is a socio-economic drought, but in terms of climate change, we usually talk about meteorological, agricultural, and hydrological drought events. And due to these events, we know there is a crop failure, there is a water scarcity, and such events are occurred due to the low precipitation and high of temperature or evaporation conditions or low soil moisture conditions. And if you talk about floods, obviously you have seen in 2025 the Punjab condition, the flood which we have observed in the Punjab state in the last year 2025 itself. Every year we observe flood conditions in Bihar. You can see the flash flood conditions in Uttarakhand, like we have Uttarakhand Kedarnath tragedy, and the last year we have seen Dharali incidents. So they are related to the flood events, and the region behind the flood condition is heavy rainfall, storm surges, snow melt, like that. And obviously it will affect the infrastructure damage and loss of life and their livelihood itself. Further, there are different other climatic extreme events we must discuss, that is cyclone and hurricanes. We know what cyclone is and what is the hurricanes associated with it, and how due to low pressure region, how these cyclones take place. In some areas it is known as hurricanes, in some countries it is known as typhoons, and some countries we say it is a cyclones. Means this is the regional name. Somewhere we can say hurricane, somewhere typhoon, somewhere cyclone itself. So these are cyclones and hurricanes which are also associated with climate change. Further, we know the heat waves and wildfires. This is also one of the most important climatic extreme events which impacts on human health, the mortality, economic impact, ecosystem, and wildlife impact itself. Because if we talk about heat waves, we observe these heat wave events are continuously increasing. And if you talk about these heat waves, they are not on increasing on the daytime, they are also increasing in the night times. So we have observed that initially before 2-3 decades, if we have any heat wave events, mostly we have a heat wave events in the daytime. Right now you can see the temperature of nighttime is also continuously increasing. So we have daytime heat waves, we have nighttime heat waves. Therefore, if we combine both, we can say compound heat waves. So that is also one of the compound extreme events or climatic extreme events. And the wildfires, we have an idea that this fire is also very important, and we are not having any fire monitoring system which can detect the fire in advance. Whenever we have a fire, then only we can detect, because we can detect the fire after the occur. So obviously we are not able to take a proper mitigation or proper preventive actions for the forest fire itself. So this is heat wave and wildfires are also most important climatic extreme events we have in India itself. Further, already I think we have discussed this increase in mean, then how this climate change is going to happen, increase in mean and variance, increase in temperature, like that. And extreme temperature is also become very frequent. Initially, we do not have some warm nights or warm days, but right now, in last few decades, the warm nights as well as warm days are continuously increasing on a global level as well as on India level. So here itself, we are showing that warm nights are increasing, cold nights are decreasing on a global level as well as on India level or on a central India level itself. We have observed that. So you can see that there are different news related to heat waves either in India or on global level. Like we have shared the example of heat waves in USA itself. Here we have shown the example 2016 cyclone in Australia. So that is one of the example of climate extreme events. 2019 floods in Mumbai. You can see the picture of how this flooding event is taking place in metropolitan cities of India or as well as on a global level. Drought in India, so we can say that 20% water left in countries' world water reservoirs. So water trains to drought impacted regions in India in 2016, 18, 19. I think we have seen the example of this in Bangalore city itself. So there are various impact of this climatic extreme events. We must need to understand if this climatic extreme events will take place, what are the societal impact we have. So obviously the very first is health, because for example if there is a flood like situations, so there will be waterborne diseases. Obviously it will affect the heat health. For example, if there is a heat wave, heat related illness will be there, waterborne diseases there will be there, malnutrition will take place due to the availability of due to the less availability of fresh food, fresh water, like that. Economy, obviously it will affect the or damage the infrastructure and productivity and migration. People will start migrating from the drought prone region to the different region itself. And there are several environmental impact we have due to climatic extreme weather event in terms of ecosystem, in terms of biodiversity, in the terms of feedback loops. Because if there is a climatic extreme events, there will be habitat loss, or due to ocean acidification, we can have a habitat loss in the means water bodies itself, ecosystem itself, and feedback loop, like that. Further, we can say what are the trends and projections we have in terms of these climate disasters. So obviously, I have either we talk about wildfires, droughts, floods, heat waves, everything is going to be increased, and the economic loss due to this climate extreme event is also continuously increasing from last we can say 40-50 years. You can see from data from 1980 to 2020, continuously loss is increasing, continuously number of disaster event is continuously increasing on a global level itself. And these are some of the impact of climate extreme events that we have to mitigate ourselves, we have to adapt ourselves for the climate change, and we have to prepare ourselves. Mitigation means we need to reduce the greenhouse gas emission. Whatever the activities which are going to emit more greenhouse gas emissions, we have to reduce that. If climate change already happens, so we have to adapt ourselves. We have to create a infrastructure which are resilient to the climatic extreme events, and we have to go for the early warning system, proper disaster preparedness, a proper resilient and ecosystem itself. So based on that, we can say that this climate change is very important, and it is our duty how we have to act in this era of climate change, whether we need to contribute to this climate change or we have to stop this change. Because for the future, it is because our future is in our hands, so we have to make a decision wisely whether we want to whether we want to live in the suffocating atmosphere where we have a drought, floods, heat waves, compound of these, or whether we want to sit in a lap of actual breathtaking nature. Here itself you can see the figure that if you will control the climate change, then you can live in this particular region where you have everything significantly good. However, if you want to sit in this suffocating atmosphere where you have the drought events, where you have the heat wave events, where you have the flooding events, where you have different type of climatic extreme events individually and in the compound form, and there are several risks associated with them in terms of we can say migration, we can say waterborne diseases, like that. So this is our decision how we need to make our climate, or how we need to make our atmosphere, or how we need to protect our mother earth from the climate change, and what we want to give to our future generation, whether this a left side picture or the right side picture. So we are the person, or we are the people who can understand the impact of climate change, understand the importance of climate change, and based on that we need to take our action, that how we need to act for this climate change issue itself. So with this I will complete this lecture, and if you have any questions or any doubts related to the lecture or climate change, I'm happy to answer the question. Thank you so much. So
Thank you so much, sir. Thank you, sir. Thank you, sir. Thank you for the informative lecture, sir. Sir, I have one question like, what are the tools you're using for flood forecasting, sir?
Okay, for flood forecasting.
Yes, sir.
Yes, means for flood forecasting or for flood determination, initially we need to have a data set related to the information related or data related to precipitation, because extreme of precipitation can lead to the flood conditions. The second important thing is extreme of soil moisture, means if soil moisture is highly saturated, obviously it will result into the runoff generation very fast, so it can affect or it can cause the flooding event. The third important thing is the runoff generation. How much runoff we are generating from any particular river basin or any particular catchment. So these are the three data set we must require to let us know what is the possibility of flood events. So these are the data set we need to have, and with the help of that we make some code for either in any particular language, it is R, Python or MATLAB, that how these events or how these data sets are contributing to the flood event. For example, if we talk about the precipitation, more than 90 percentile of precipitation will leads to the flood events. That is can be condition of that. Similarly for the runoff generation, similarly for the soil moisture condition. So that we need to because we are not using any particular software for flooding events, but we can code this thing into any particular language. And if you want to forecast this flood events, what we can have from the CMIP6 climate models, what we have discussed in this lecture. So this from the climate models, that is CMIP6 or climate model GCMs, we can take the data of future from 2025 to 2100 in terms of precipitation, in terms of temperature, and with the help of that precipitation data we can forecast the flood by using this threshold of 90 percentile or 95 percentile, that if the precipitation is increasing or passing the threshold of 90 or 95 percentile of precipitation, then it can result into the flood generation. So with the help of that future climate data from CMIP6, we can forecast the flood events.
So do we have any data set of already happened floods, the historical flood events, like how much discharge technically, not only based on the location? So for this precipitation, this is the flood depth that was happened. Do we have any data set like that?
That is not consistent throughout any particular region. That is varying with the region itself. For example, that's why we have set a threshold, not in an absolute term. Whenever we say about any particular extreme event, for example, you say about the flood. So we cannot set a threshold that if the discharge is above this value, it will result into the flooding event. Maybe that particular discharge value in a one particular region can cause the flood event, but for the other region it may not leads to the flooding events. Therefore, whenever we talk about climatic extreme events, we never set a absolute threshold. We set a threshold in the percentile value, because for a one particular region 90 percentile can be other value, and for another region 90 percentile can be anything else. For example, if you talk about the temperature also, maybe in Manali the 90 percentile temperature condition is less than 30 degree, but for Rajasthan like Jaipur, we can have a 90 percentile, maybe it is 45 degrees Celsius. So we cannot say ki less than 35 degree or more than 35 degrees Celsius will leads to the heat wave condition, because in Rajasthan or in Jaipur condition, more than 35 degree will not result into the heat wave condition. However, maybe in Manali it can be like that itself. So we have to make a threshold, not on absolute term, make in percentile value, so that it will take an average of that particular region, of that particular grid, rather than same value for whole river basin or whole state or on particular national level. We cannot use a absolute threshold.
Okay, sir. Okay.
Yeah. Any other questions?
Ma'am? Aishwarya ma'am, shall we
Yes,
wind
ma'am.
up?
Yes, ma'am.
Okay.
Sure, ma'am. I sincerely thank Dr. Vikas Punia, who is also my program coordinator for the AICT QIP course that I've attended in Bhopal. So I'm extremely thankful for him for the support given during the QIP as well as for this event. And we look forward for continuous engagement. So thank you so much for gracing this occasion, for giving the talk on climate extremes on this generic talk series. Thank you so much. Thank you so much.
Yeah, thank you so much for inviting me. Thank you.
Thank you, sir. Thank you, sir.